Alright, ladies and gentlemen, welcome to your first Chem 11 video. This one's all talking about naming and writing formulas, but more specifically, we're going to spend time on the ionic formulas today. This is just a little bit of a recap from Science 9 and 10, but it still is pretty tricky, so we'll go through this so you have a little bit of a template to fall back on. So first of all, we have our periodic table of elements. We break it down into kind of our metals and our non-metals. Metals are going to be on this side, and our non-metals are over here. So in an ionic compound, it consists of a metal and a nonmetal, whereas in a covalent compound, it consists only of nonmetals that are bonded together. So let's just get a little bit of background here. Monoatomic basically just means that there's one element sitting together. So if you just look at O, just oxygen. If there's diatomic, it means that it's going to exist in twos. These are the big ones. We call this one Hofbrinkel, because, oops, almost forgot one. These are the elements that are going to exist in nature as only in twos. So H2, O2, F2, Br2, I2, N2, Cl2. So write those ones down. We also call them like the Super 7 because there's 7 of them. Triatomic, you don't see it much. Things like ozone, O3, polyatomic, more than. These are things like PO4, 3 minus, phosphate, SO4, 2 minus. These are on the back of your periodic table. So these are not elements, okay? These are multiple elements together. So let's look at the actual process of writing ionic formulas. The first thing that you're going to want to do is when you're given a compound name is you're going to want to find the symbol. And that's on the periodic table of elements on the front. Then you're going to want to find the charge, and then you're going to want to balance the charge. So let's look at sodium chloride. Sodium's Na, chlorine's is Cl, and we found that on the periodic table. If you look at the charge of Na, it's a +1, chlorine is a -1. So all atoms, when they come together to form compounds, which means multiple atoms, these are going to be neutral, which means that there's no excess of charge. So if it has one positive, it'll have one negative. They're balanced. So if you look at this one, if we brought a sodium ion and a chlorine ion together, it's a 1-to-1 ratio. Those cancel off, and it's neutral. And then that's what we wanted. Okay. Whereas if you look at lithium, is Li, oxygen is O, 2 minus charge there. This is 1 plus. If you look at this here, there's 2 negatives and 1 positive. They don't balance off. The only way that you can balance this is if you had 2 positives. So what you would need is 2 lithium atoms to cancel off that 1. So what that creates is 2 lithium atoms for every 1 oxygen, if we count them up. Okay. Another way that we can think about this is the swap and drop. When we have these charges, what we do is we keep the elements the same, but we swap the charges and we drop them down to the bottom. So now the 2 will be on the lithium and the 1 will be on the oxygen, but if it's a 1, we don't have to write it, we can assume it's there. So what I want you to do right now is to try this one out here, magnesium. So pause it right now and try to do this one on your own. So I'm assuming you're back. So what we have is magnesium 2 plus, fluoride minus. When we swap and drop it here, we're going to have magnesium, fluorine 2. Because you need 2 negatives to cancel out that positive 2 charge. And then aluminum selenide. So in this situation, the selenium was a -2 charge, and so we had to make sure that we had enough charges. So we need to have, this is a tricky one, aluminum 3 plus, selenide 2 minus, selenide 2 minus, selenide 2 minus. The only combination that would cancel each other's charges off is if we had 2 of these and 3 of those, because that makes it for 6 positives and 6 negatives, which creates Al2, Se3. And just a heads up, if this is pretty confusing coming down, the main point of these videos are just the quick introduction to the concepts, and we go into depth when we get back into class. So let's look at the polyatomics. We already mentioned one up at the top here. It's going to be the exact same type of stuff, but instead it ends in 8s or ites. Okay, so let's continue on here. Barium nitrate, same charges or same process. You find the symbol and the charge. Look on the back of the table. We know it's the back because it's got an ATE ending, and it's NO3 minus. What we're going to end up doing, we do our little swap and drop. So we get barium. It gets this minus, or it gets the 1, and then nitrate gets the 2. But if we just put the 2 down like this, that's going to say NO32, and that's not what we want. We want to show that there is 2 of those nitrates. So we put it in brackets. Okay, zinc phosphate, 2 plus, phosphate is 3 minus. We swap and drop those ones, so we're going to get zinc 3 and phosphate 2. Okay, stop and try this last one out. So pause it now. And we're back. So ammonia is a little bit more tricky. NH4 plus, it's our only positive polyatomic ion we'll be dealing with. Sulphide is a 2 minus, but we do the same thing. Swap and drop. That NH4 will need 2, so we put it in brackets, and then S. So what we have next is our Roman numerals. Roman numerals are used for when we have elements that have more than one charge on the periodic table. So look at your periodic table. So I'll just zoom back up here for a second. A lot of the ones here in the middle called the transition metals have more than one possible charge. Like iron has a possibility of 2 plus or 3 plus. Well, how do we decide which one we use? Well, we have to put Roman numerals to show which one we did. So here are your Roman numerals, so you can write these down. Okay, so you can get those down. So what this is showing now, if we normally picked iron and oxygen, we know that oxygen's charge is 2 minus only when we look in our periodic table, but now iron has a choice of 3 plus or 2 plus. So the nice thing for us with the Roman numerals, it tells us that the charge that it used was 3. So then when we do our swap and drop or our balancing of charges, we're going to end up getting iron 2O3. Same thing here with chromium carbonate. Chromium, it's showing that it's a 4 plus charge. Carbonate is a 2 minus charge. Just like anytime we have fractions or ratio, they have to be in lowest terms. When we do our swap and drop, we would get Cr2, CrO3 with a 4, but this isn't the lowest reduced form, so we have to simplify it. And finally, try this last one out on your own. So pause it now. Then we end up getting H1 plus, chlorine 1 minus, and we end up swapping. There's nothing to swap, so it's a 1-to-1 ratio. All right, moving right along into the naming of the ionic formulas. These should be pretty straightforward. All you need to make sure that there is check the metal to see if it's got more than one charge. If there is, you need to make sure you use the Roman numerals. And then for the non-metal, all we're doing is changing the ending to IDE. And if it's a polyatomic ion, you leave it the same. Okay? So let's look at a couple examples here. So this first one, we look at the first thing we write down. It's magnesium, so we write down magnesium. There's only one charge of magnesium, so we don't have to do a Roman numeral. The second word or second element is bromine. So instead of INE, we change it to IDE, and that's it. So magnesium bromide. Next one, we have iron. There's more than one choice, so we'll get back to that in a second. Sulphate is the SO4. Sulfate's charge is always 2 minus. So what you have to distinguish between is you have a 2 plus charge or a 3 plus charge option for iron. When you look at these, if you use 3 plus coming together with a 2 minus, you would not have gotten this formula. The only way to get that is that since it's a 1-to-1 ratio, is if that was a 2 plus charge. So we show it as a 2 plus charge with our Roman numeral 2. Okay, barium is Ba. There's only one choice for that. OH on the back is hydroxide. Okay, and then you guys pause right now and try these other three. Okay, finishing off here, the last couple things. We also have things called hydrates. All this is just a little addition onto any of the compounds we have so far, and all it is water molecules that are attached. We use the same same prefix system that we used eventually in the covalent compounds. So if there's one water molecule, we say mono, 2 di, tri. So for example here, this one, copper CuBr2 is normal. So copper, it's got more than one charge, but since bromine's always a minus, this must have been a 2. So bromide. And then we say dihydrate because it shows that there's 2 water molecules together. Hydrate is in needing water because you need to get rehydrated, so that's how you can remember that. A lot of common errors, people just do the 2 and think H, but it's not, it's H2O. Okay, and the last one here, we have iron 3 chloride, and then we have hexa because there's 6 hydrate. Okay, so I'm sure we're going to have lots of time to plug away at these, lots of practice problems tomorrow. If you have questions already, write them down.